So we've talked a little bit about instance data variables. I want to broaden that conversation a little bit and talk more generally about data scope. So the scope of any variable is the area where it can be used or referenced. So different variables can be seen or accessed from different parts of your code, and that's the scope. And that scope is determined by where the variable is declared. So note, it's not by where it's initialized, it's where it's declared. So it's that very first step where you specify the type and the name of a variable. Where that happens in your code determines the scope of that variable. So far we've seen two different kinds of variables. We've seen instance data variables, and the key there is that those variables are declared in the class. So if we look at our die class, face value is declared inside our class brackets, but outside of any method. That's what makes it an instance data variable. Because it's instance data, it can be used anywhere in the class. So any of my methods can access face value, and you see that they all do, right? I access face value in my constructor, in my getter, in my setter, and in my toString. And all of these methods are allowed to access that variable because it's instance data. And again, it's instance data because it's declared inside the class, outside of any method. Instance data variables stick around as long as the object sticks around. So if I declare an object called die1, the face value of die1 is going to be saved in memory as long as die1 is saved in memory. So the instance data variables are kind of tied to that object. As long as the object lives, the variable, the instance data variable lives. Those two things will be saved in memory together. Now, another kind of variable is a local data variable. A local data variable is a variable that is declared inside of a method. So we saw an example of that in our toString method. Here, I declared a variable string s, and I set it equal to some value. Here, I combine the declaration and the initialization into one line, but still, this is the declaration part. This is where I first specify the type and name of my variable. And because this happens inside of this method, right, it's inside the method bracket, so it's inside this method, that makes it local data. Okay, so local data is declared inside of a method. Local data variables are only able to be used inside that method. So if I wanted to access string up here, or I'm sorry, s up here, I can't do it. And in fact, I get a compiler error saying s cannot be resolved to a variable because s is invisible everywhere else except inside this method. So s can only be seen inside this method, and that's true of all local variables. So s is a local variable because it's declared inside of a method. And that means it's visible and usable only in this method. Nowhere else. Okay. This also relates to how long this variable is stored in memory. So essentially, local variables are forgotten as soon as the method ends. So when we hit the end of this method, s goes away. So it's only stored as long as the method is running. As soon as the method is done, s is forgotten. It's lost from memory. In Java, that's called garbage collection. Garbage collection is the process of clearing up and freeing up memory we don't need anymore. And for local variables, that happens as soon as the method ends. Okay, so these are two types of variables, instance data and local data. And again, you determine what kind of variable you have by where it's declared. And once you know that, then you know about where it can be used and how long it's going to stick around in memory. Now, one of the big ideas in Java is encapsulation. This is a big idea in general in object-oriented programming. And encapsulation refers to the idea that every object protects its own information. And remember, the information that describes an object is the instance data. So each object is in charge of its own information. That's the idea about encapsulation. It means that every object kind of keeps private and protects its own information. So here, when we declared face value to be private, this means only the die class can access it. It's only accessible inside this class. Other classes cannot directly come in and manipulate this variable. And that's the idea of encapsulation. This class is in charge of its own information. And that makes sense, right? That a die is in charge of keeping track of what value is showing, and other classes wouldn't be in charge of that. It's the responsibility of that class. So encapsulation really kind of follows this whole idea of classes defining what an object looks like and what an object can do. And part of what that object has to do is keep track of its own information and modify its own information and specify how those things happen. So while it protects its own information and keeps it private, it also does provide public methods so that other classes can access that information, because the die class would be pretty useless if we didn't have a way of looking and seeing what number was face up, right? So we want to provide public methods to provide access to that information, but in only the ways we specify, okay? So this idea relates to the idea of a client. So the client is a class that uses another class. So right now we don't have a client class. Right now I've only declared my die class that specifies what a die object is going to look like. And I haven't written a client class to actually use the die class. We're going to do that in next week. But right now I haven't done that. If I were to write another class of that created die objects, I would call that a client class, and that class would use my die class. Now, changes to an object state, which is its instance data, are made only through methods. That means the client, so that other class that's using my die class, can't access my instance data directly. It can only access it through the public methods. So I can't have some other class I'm not going to allow some other class to change this variable unless they do it through using my public getters and setters. This is encapsulation. That's what supports encapsulation. Another thing that supports encapsulation is only allowing the client to access the information again through these methods, but the other client class doesn't know how those methods are implemented. So it knows what things the object can do. It knows that the die class is going to have a series of public methods. These are called often service methods, saying, hey, here's what a die object can do. But the client doesn't know how it's doing it. So it doesn't know what code I've written behind the scenes to make those methods run. It just knows what the methods are. So this idea about writing a class and then using a class as a client, it's sometimes kind of hard to think that way. You sort of have to put on two different hats, right? You're putting on your one hat to write the class, and then next week we'll put on a different hat to use the class. And throughout this semester, I'll ask you to kind of wear both hats, right? But you got to think that way. You need to think about, okay, when I'm designing my class, I want to write things a certain way, like keeping things private and providing public methods to access those variables. And then when I go to use the class, I have to think about, put on my client hat and say, okay, all I know is that I have these public variables, or these public methods rather. I don't know anything else about what's going on inside that class, and I don't need to. I just know I'm going to use these public methods to access that object. Okay, so let's talk a little bit about visibility modifiers, because that relates to the idea of data encapsulation like we've been talking about. So public, if you have a public modifier on either a variable or on a method, it means it can be referenced anywhere. So if it's a public method, any other class or any other client, you might say, can use it. If it's private, it can only be referenced within that class. So if I were to change this getter to be private, that means that no other class outside of the die class can invoke this method. They can't access it. They can't even see it. That'd be pretty silly for a getter method, because that's the whole point, is to allow access. So I'm not going to do that. But any private method is only visible within the class where it's defined. Now there are two other types of visibility, protected and default. Protected is related to inheritance, so we're going to talk about that later on when we talk about inheritance. And default visibility, which is essentially meaning you leave off a keyword altogether. So you don't put the word default, but you just leave off a visibility modifier, means that that variable can be referenced anywhere within the package. I am going to ask you to stick with just these two visibility modifiers for now, public and private, and we'll learn a little bit more about the other two later on. So for now, you're going to keep all of your methods and variables either public or private. And you're actually not going to keep your variables public because that violates encapsulation. So if I were to make this variable public, that would essentially mean that a client class could come in and directly access this value and modify it to be whatever they want it to be directly. They could get their hands on it. And I don't want to let them do that. That violates encapsulation. Encapsulation says that only die objects should be able to modify their own information, not some other client class. All that modification should be kept within the class itself. So I am never going to make my instance data variables public, and you shouldn't either. Making instance variables public violates encapsulation, so do not do it. Okay? Keep your instance data variables private, and then provide those public methods to access and modify the values appropriately. Okay, now constants, we talked a little bit about constants before. Constants, it is okay to make them public, and that's because by definition their value can't be changed. So you don't run the risk of having a client class come in and change the value in a way you don't want because they can't be changed anyway. So it is okay to have a public constant. That does not violate encapsulation, but again, it is not okay to have a public variable. So we're going to keep all our instance data variables private. For methods, we can have a public method or a private method. If we make our method public, that means we want to allow other clients or other classes to be able to invoke that method or use that method. These are often called service methods because you can think about a class's public methods are kind of the services that it offers. Hey, here's a list of things that this object can do. These are all its services. If you had a method that was just going to be kind of a helper method or something that only needed to be used internally, that would be a private method. That's a method that's not intended to be seen by an outside class, but really only meant to support the internal workings of your class. That method should be kept private. So here's a little summary. We have variables and methods, and they can be private or public. Variables, private methods support encapsulation. That's good. Public methods violate encapsulation. That's bad, and we're not going to do it. No, never. Right? Methods can be private or public. A public method is a method that provides a service to a client, and a private method is a method that supports other methods within the class, but can't be invoked outside the class. So when you're writing your classes, you want to think about, okay, should this method be public? Do I want other classes to be able to access it? Or should it be private, meaning I only need to kind of use this method internally. I don't need to allow other classes to access it. Okay, so here's our summary so far of what our classes look like. All of our classes contain private instance data variables. They contain our constructors, the purpose of which is to set up our objects. They contain public getters and setters for all of those instance data variables. They contain a toString method that is a public method that provides a text representation of our object. And then they're also going to contain a series of public and private methods that support other functionality related to the class. So again, these four components are kind of always going to be there for all classes in a similar format. And then this last one is going to be different depending on what your actual class is.